Okay, so converse of the Pythagorean theorem. So we just talked about what a converse is. It's when you reverse a mathematical statement and it's still true. So here it is. So I'm going to write down the converse of the Pythagorean theorem. If the sides of a triangle follow a squared plus b squared equals c squared, then the triangle is a right triangle. Okay. So this is the converse. Converse means when you reverse the order of something and it's still true. So this is the converse of the Pythagorean theorem. So if the sides of the triangle follow the order a squared plus b squared, and that equals c squared, where a, b, and c are sides of the triangle, then we know we have a right triangle. But it even tells us more than that. Some other mathematicians kind of played around with it and discovered a little more. So these are all the other conclusions. Okay. Conclusions. So if we have a squared plus b squared and it's greater than c squared, meaning a squared plus b squared is a bigger number than c squared, we have an acute triangle. You guys know what an acute triangle is? Yeah, all the angles are less than 90. Okay, that's one conclusion. Then, of course, we have the one we already know, a squared plus b squared equals c squared. That's a right triangle. So that's our second conclusion. And there's only one other possibility. Yeah.
Which is the opposite of acute, right?
Mm-hmm. So that would be a squared plus b squared is less than c squared, meaning c squared is bigger. And that would be an obtuse triangle. Okay. So without looking at the triangle, as long as you tell me the length of each side, I can tell you what type of triangle we're going to have. Okay. So we're going to work with this. So we're going to make a little table and play around with this. Okay. Let's do this. Let's say this is the dimensions. That's going to be the length of each side. And so we'll write the dimensions down. And then we're going to do a little bit of work. We'll come up with a conclusion. And finally, we'll draw a sketch of what that triangle should look like. Okay. There we go. So go ahead and write that down. So I'm going to give you 3 sides. And then let's figure out what we have. You guys ready? Let's say these are the 3 sides of a triangle. We don't know if it's a right triangle yet. 30, 15, and 45. Okay, go ahead and write that down. 30, 15, and 45. That's the length of all 3 sides. Let's label them first. Which side has to be C? 45. The longest side, even if it's not the last number. So this could be A, this could be B, and this is going to be C. Okay, so the first thing we're going to do is do A squared plus B squared and compare it to C squared. Okay, so we got calculators. We could do this right now. We want to do, let's see, instead of A squared, we'll have 30 squared. And we'll add that to 15 squared. And we're going to compare that to 45 squared. Okay, so let's see. Let's square 30. That would be what, 900? And then 15 squared is 225. And then 45 squared, that's 45 times 45.
That's 2025.
So the question is, which is bigger, 900 plus 25 or 2025? 2025 is going to be bigger. Okay, so our conclusion is, what kind of triangle do we have? Okay, let's draw one. I'm going to try my best to draw an obtuse triangle. So an obtuse triangle has one obtuse angle. That looks pretty obtuse, right? So there's my obtuse triangle. And let's say this is 45, 30, and 15. Maybe that's our triangle that we're looking at there. Okay. Okay, ready for another one? All right. Well, that was pretty. I feel like that one was pretty easy for you guys. Number 2. 7.5, 12.5, and 10. Try that one. Okay, which one has to be C?
12.5. 12.5.
Yeah, that one has to be C. So then we can have this as A for 7.5 and B. Okay, so same as before, A squared plus B squared, we'll compare it to C squared. Okay, so this time we have 7.5 squared plus 10 squared. And we're going to compare it to 12.5 squared. Okay, so let's square some numbers. So 7.5 times 7.5. And I know the other one's 100, so I'll just put that. All right, 12.5 squared. What's that going to give us? 100 and 0.25. So which one's bigger? They're equal this time. So what's our conclusion? A right triangle. It has to be equal. Okay. So let's draw a right triangle. Okay. And let's label our side. So the side that's 12.5 is a hypotenuse. The slightly longer side leg will be 10. And this leg that's a little shorter will be 7.5. Okay, let's continue. Okay, you guys ready? Let's do number 3. Let's do 21, 15, and 17. Which one's going to be C? Okay, and so 15 could be A, and B is going to be 17. Okay, so you tell me, work it out.
What do we got?
So we want 15 squared plus 17 squared compared to 21 squared. All right. So 15 squared, that's 225 plus 289. Thank you. And then 441? Okay. I can't tell for sure. Let's add those up. What do we get when we add up these two numbers? 514. Thank you. And we're comparing that to 441. This time, which one's bigger? 541? So 514 is bigger than 441. What's our conclusion? Acute triangle. Okay. So an acute triangle, all the angles are less than 90. Maybe something like this. Something like that, maybe. And let's say, I don't know, 15, 21, and 17. All right. So the main thing about the converse of the Pythagorean theorem is it'll tell you, is it a right triangle or is it not? So that's the main thing we're going to look at today. But you can get all this extra stuff along with it. And I just wanted to make sure you had that knowledge. Okay? So the assignment is going to be on IXL, and it's going to ask you, is it a right triangle or is it not a right triangle? And the way you figure that out is Pythagorean theorem, the converse of the Pythagorean theorem. Okay?